Hi there, I'm Carys Bill, and I'm an incoming PhD student at Imperial College London. I've just finished my degree at Oxford, hence I've got a new email here on the right. I'm very grateful to be here today, and thank you all for a really great conference so far. I'm here today to talk about a project I'm working on analysing the environmental impact of the InSight mission. I'd also like to acknowledge the great team I have here who've helped support this work, and the wider InSight science team who've supported and contributed to this work. And hopefully lots of you here will be interested in this, working on current and future missions. So why are we undertaking this work? The environmental footprint of planetary missions is poorly understood and understudied. Here's a figure showing how few papers we could find relating to the environmental impact of planetary science. So far, planetary exploration has done some amazing work in improving our knowledge of our environment and climate, and will hopefully continue to do so. However, as planetary scientists, our work emphasises how unique and special our Earth is, which positioned to know better than anyone else that there is no planet B. To help our society tackle climate change, we need to take more responsibility ourselves, improve accountability and awareness of the environmental costs of planetary exploration. This will help us identify areas for potential reduction and help ensure the future of planetary exploration, so that future generations, including the significant number of students like myself at this forum, can continue to enjoy space exploration in many years to come. So how are we implementing our work? So we've made this framework that you can see here, and we're currently looking specifically at evaluating the carbon impact of the InSight mission. We've defined a scope. For example, we're only looking at emissions which are directly due to the mission. We want to look at emissions from the mission participant and as well as the mission activity specific carbon costs. And we also ideally want to look at the costs from mission initiation until the mission end. So then we've gathered data and I've calculated estimates for the total CO2 costs for different aspects of the mission. So we've identified 5 different key components of the InSight mission: the launch, team meetings, manufacture, operations, and communications and science activities. We conducted an opinion poll for thoughts on the biggest contributing component at our last science team meeting in March, and the results are shown here. InSight team members thought that the biggest contributors to the environmental footprint of the mission are team meetings, the launch, and manufacture, respectively. So the biggest proportion of people voted for team meetings. Team meetings and in-person interactions are invaluable for opportunities for networking, collaboration and discussion. I'm certainly feeling a little bit of FOMO as I was not able to be with you today. But at what costs do such opportunities come? We've attempted to quantify the carbon footprint of the last science team meeting held in March and shown in the bottom right picture here to explore the environmental cost of such opportunities. So we first looked at the flight path of meeting attendees. As demonstrated by this figure, InSight is a mission with lots of international collaboration, which contributed to its success. However, at the last meeting alone, air travel came at an estimated cost of 45 tonnes of CO2. For comparison, that's around 4 times the annual per capita CO2 footprint in Europe. We then factored in other components like food, accommodation, and building energy consumption, leading to an estimate CO2 cost of 60 to 80 tonnes for the meeting. As you can see by the relative sizes of these bubbles in the figure, transport to meetings is by far the biggest environmental cost. So we then looked at the meetings for the mission as a whole. The COVID-19 pandemic highlighted how we can work effectively remotely, and it likely reduced the overall meeting-related footprint of the InSight mission. Nonetheless, many in-person meetings did occur in both the USA and Europe. And using the data we gathered from the questionnaire asking about where people had flown from, we actually calculated that the most carbon efficient meeting location would be on the East Coast. We could then actually halve this footprint from travel if we split the meeting into 2 concurrent meetings, one in Europe and one in the USA. And then only holding one in-person meeting per year, rather than 3 or 4, could significantly reduce the footprint from travel once more. So with travel to meetings identified as a significant contributor, we've calculated a current estimate for the CO2 cost of all InSight science team meetings at 1.3 to 1.6 kilotons of CO2. We've also looked at the environmental cost of the launch. Here's a fab picture of Brisbane, the InSight PI, in front of the Atlas V with InSight ready for launch. Looking simply at only direct costs, the launch actually costs less than a kiloton of CO2, or roughly the carbon equivalent of 2 full Boeing 787 return flights from Los Angeles to London. Moreover, the carbon cost of launch is actually likely less than the footprint of team meetings, which, as shown by the opinion poll at the start, was not what a lot of people might expect. Work to analyse and calculate the environmental costs of the other identified key components continues. For operations and communications and science activities, computational costs are likely a big element. Our estimates here need further refinement. For manufacture, there will be many pre-launch elements to consider, including production, testing, transport of parts, and transport of workers. Gathering for this is data for this is a challenge at this late stage in the InSight mission, emphasising how implementing environmental cost tracking from mission initiation could be beneficial for similar work on future missions. So let's return to this initial opinion poll. So far, we've estimated the carbon cost of team meetings and the launch, and have so far found that the team meetings is greater than the cost of the launch. And so the carbon cost proportions may look something like this. But as already mentioned, work is ongoing to better estimate and constrain the remaining 3 aspects. Based on what we've learned from travel to team meetings, I also imagine that manufacturing carbon costs could dwarf the other components, given the air transport required for parts and workers. So the proportions could actually end up looking a bit more like this, or possibly even greater for manufacture. And so looking to the future, there's ongoing work to look at the InSight mission as a whole. Hopefully we can produce some further numbers and estimates that will help identify more areas for reduction. It would also be really great to see sustainability working groups and environmental cost tracking become a part of all planetary missions, ideally from mission design until mission end. The more we look at the environmental impact of missions, we'll be able to improve our understanding and improve the data needed for greenhouse gas generation rates, and not just look at CO2, but other gases too, and look at the environmental impacts associated with planetary exploration in a wider context, and refine our estimates. By doing this, we can hopefully identify areas where we can improve the sustainability of planetary exploration missions, so that the future generations can continue to enjoy the exciting prospects of space exploration too, and also play our part in helping society face the immense challenge of climate change. So I'll end there, and thank you very much for listening. And if you've got any questions, please go ahead.
Wonderful, thank you. We have time for a question or two. Okay, we got a question. Hold on.
Hi there, Micah Scheibel, Georgia Institute of Technology. I was wondering, with the transportation costs, if you counted for stops, because a lot of those international flights are going to stop over somewhere on the way.
Yes, so I took all the data, asked everyone to detail what their different connected flights were as well, and then looked at the research that shows the extra energy and extra cost of actually launching the plane into the air. And also, more recently, we added data based on contrails, which I hadn't appreciated are quite a big CO2 contributor to flights as well.
Any other questions? Oh, okay, we got another one over here. And also to check online for questions too.
Hello. Did you consider the value of the science team missions versus the cost, like the reviews being done and, the necessity for those meetings? Or did you look at it as just straight cost?
So far, we've only looked at the cost, but of course, we appreciate that there's nothing can really replace in-person interactions. But also, if we try and be more accountable, then we can hopefully find a balance between make sure we can enjoy exploration, but also it's sustainable for the future.
Thank you.
All right, wonderful. Thank you.